All right. Back in business, folks. We got some covalent bonding about ready to rock and roll here with. So let's do this. Let's draw what a water molecule would look like. So we're looking here. We need to know some information. I should see that I have 2 hydrogens to work with and 1 oxygen. So we're going to pay attention to what's going on with the electrons. Really, the concept of bonding is what is happening as we reconfigure where these electrons are going and what they're doing. So sharing tells me something. We're going to be talking about the covalence or covalent bond here. So let's draw this out structurally. I know that both hydrogens are going to have 1 proton and 1 electron, and I know it only has 1 AMU, so therefore it's going to have 0 neutrons. So this is my information I'm going to have to work with. And oxygen is going to have 8 protons, 8 electrons, right? Remember, these are 0 net charge naturally occurring. So this as I have 1 proton, 1 electron, they cancel net charge. 8p plus, 8e minus, 0 net charge. I have 16 AMU. I get this from the periodic table. It shows me I have 8 neutrons. So obviously protons, neutrons go in the nucleus. So let's draw this. Let's do this. I'll draw oxygen first. So oxygen first. Let me give a little space here. Oxygen's going to be, I've got 8 protons, I've got 8 neutrons. In my first electron shell, I have 2 electrons. Bingo. So my first electron shell, let's make sure let's say electron shells. You can call them orbitals, whatever, again, doesn't matter. And the first wants to house 2 electrons. Second wants to house 8 electrons. Third, 8 electrons. And fourth, we'll stop here, 18 electrons. So we have these rules. So this is what it wants to satisfy the stability. To be done reacting, it wants to get to this point here. And therefore, I have 8 electrons total. Bingo. And I've used 2 in my first one. So that tells me I have 6 electrons here. And I'm going to draw them like this. 3, 4, 5, 6. I will just distribute them. So now we're going to draw our hydrogen. And my hydrogen is going to have 1 proton and 1 electron. And over here I'm going to draw my proton, and it's going to have 1 electron. So you might say, okay, something's up here. Something's up. I've drawn this out structurally. They're simple, right? Just 1 electron, 1 proton represents this hydrogen atom. So something has to happen here. If they're both going to satisfy their electron rules, there's this one. The hydrogen needs 1 electron, so it says, you know what? Let me kind of jump in the mix here. Let me borrow this one. And let me borrow or share this one with you. And notice, when you look at this from a structural standpoint, and I'll draw in a little different color here, by sharing here, we have just opened up the door for this is a covalent bond. Covalent involves sharing. That hydrogen, this hydrogen gets 1, 2 electrons. That's how many it wants in the first shell. This hydrogen gets 1, 2 electrons. That's how many it wants. However, look at what happens with oxygen. It gets 1, 2, 3, 4, 5 share 6, 7 share 8. It gets to satisfy its rule as well. So both hydrogen and oxygen get to share their electron, let's just say their electron rules to stabilize them after they've reacted. So H2O is, in this case, they've reacted. They've relocated what is taking place with their valence electron. But something unique also happens, and this is what I want to make sure we identify in terms of polarity. The polarity of what's taking place here is, if you can think of these as little magnets, we can talk electromagnetism here. The 8 protons are going to be a stronger magnet than 1 proton. So they're going to pull, the nucleus of oxygen is going to pull these electrons inward, closer to this nucleus. This is just a stronger magnet than, say, 1 little measly magnet. And what happens here is this end is going to have a slightly positive net charge, and this side here is going to have a slightly negative charge. And notice, when we talk terms polarity, we simply have a positively and a negatively charged end or side to the water molecule itself. So a lot going on here. You should be able to draw it out structurally. Should be able to take a look at what's happening with the valence electrons. Have they established their electron rules? And lastly, what is the net result? In this case, water is a polar molecule.